The problem in this video is just like one that is on your test. Or maybe not just like, but very close to one that is on your test. I would encourage you to try the problem and then check your answer with the video and make sure you understand every step. So I was just watching football with Mr. Thopper, and I saw someone kick a field goal from about 30 meters away. And I was thinking, I wonder how high the ball is when it crosses the goal line. And so, you're going to solve that problem for me. A kicker wishes to kick a field goal, so he sets the ball on the ground at a distance of 30 meters from the goal. Assuming he kicks the ball at an angle of 45 degrees at a speed of 27 meters per second, what is the ball's height above the ground when it goes over the crossbar? Now, there were some football terms in there, so let's draw a picture to make sure everybody's clear. Alright, here's going to be our football field. And over at the end of it, we will have the goalpost. Here is our kicker. And maybe he's wearing a little football helmet with some kind of face mask. According to this problem, our kicker is 30 meters from the goal. 30 meters. And if that problem, if you're like, wait, I don't know what it means when it goes over the crossbar, it just means when it gets to the goal. So after the ball goes 30 meters, what is the ball's height above the ground? Okay, so he kicks the ball at 27 meters per second at an angle of 45 degrees. That's a vector, friends. So, some steps you're going to have to take to solve this problem. Resolve that vector into its component parts using sine and cosine. So find its y component, find its x component. Find those components. Figure out how high the ball is, what its y position is at 30 meters. Okay, copy down anything you need to. Maybe take like 5 minutes, go try this problem. And on the next slide, I'm just going to give you the answer real fast. Okay, so let me walk through this real fast. I've been conscious that my last few videos have been pretty long. We know V naught is 27 meters per second. I'm reading from the top down. We know our final x position is 30 meters. That's how far the ball goes when it crosses the goal. Therefore, V naught x is 27 times cosine 45 degrees meters per second. Trig functions from 2 days ago. V naught y is 27 sine 45 degrees meters per second. Now we can find time. Remember I told you that's always super helpful to know, time. What time it is when the ball goes 30 meters. So x, now reading in blue, I color-coded x and y. Blue, x equals V naught x times t. And that's just reduced down from the big x equals x naught plus V naught xt plus 1/2 ax t squared. So 30 meters equals 27 cosine 45 meters per second, which is V naught x times t. Then I grabbed a calculator, solved for t, and got 1.6 seconds. You might want to confirm that that's correct. Then I went over to y. Y equals V naught yt plus 1/2 at squared. I don't have an initial y position, it's on the ground, and I told you to cleverly define the ground as 0. So, fill in the y equation, 27 sine 45 degrees meters per second, times 1.6 seconds, plus 1/2, and then I had to go down to the next line. Ran out of room. Times negative 9.81 meters per second squared. If I set the ground as the origin, up is positive in y, down is negative in y, and so gravity pulls down, negative 9.81 meters per second squared, times the time I found from x, 1.6 seconds squared. And then if I do out that math, my final answer is, drumroll please, I'm going to have to write it a little above, y equals 18 meters. Mr. Melvin, you went through that problem really, really fast. Yes. This is the speed you're going to have to get used to doing these problems at. If you want a slower example, rewind the video to the last one. This uses the exact same concepts, exact same equations, just arranged in a different way. Alright, there's extra practice on the website. Also, Handily, your book has lots of problems in it. The ones that have one little red dot are things you should all be able to do on your own, And then the answers to the odd-numbered problems are in the back of the book. So, if you look in your book at the problem sets for Chapter 4, some problems have one little red dot by them. Pick a few from Section 4.4. Try them, check your answer in the back. That's all. See you tomorrow.